Okay, I'm just going to show really quick how to do a couple of these CAD modeling things. We've got the drilled holes. Um, the dimensions for the drilled holes in here, these are correct, so you got to follow those. But if you go to the next page, you can see all the settings a little more carefully. Now, keep in mind, these settings, guys, they don't, the screens in the modern version of Inventor don't exactly look the same, but all the same settings are there. It's just a matter of finding them and figuring out which is which. Um, so in your 3D model, you hit a hole, and it automatically selects all of the visible points in your drawing. So what you can do is you can hold down Shift and deselect some of these. Now that first hole's in there, probably shouldn't be, right? What we can do is we can go back and check that in a second. Um, that one is the through hole, which isn't really a through hole, it's a simple hole, and it goes a certain distance. I don't know why they called it through hole here. It's not actually. So the next one, though, is the counter bore. So this shape here is a counter bore. And you see screws like this, you ever screw something in, you buy something, put it together, and you want the screws head to fit flush with the surface. It's either a countersink or a counter bore. It depends on how the screw head is shaped. Um, anyhow, so counter bore, and then the stats for the counter bore are here. It's 0.75 inches wide, 0.25 inches tall, the bore, and then the width of the hole overall is 0.375, and it goes through everything, it goes through the whole thing. So it's going to be a counter bore. It's a simple hole, all right? These other options we'll use in a second. It's a simple hole with a counter bore seat. It's called a seat. And I do need to select the hole I'm working in there. Then it's just a matter of kind of modifying this stuff. This is 0.75, 0.25 is the same. This is 0.325. Termination, through all, right? So that's going to go all the way down to the bottom. Hit OK. All right. And if you're wondering why this is transparent, it's because it's got a plastic selected. Lexan, smoked. That's like, a tinted plastic. So that way, when you look at it, you can see through it and see what's going on with the holes. All right, so I'm going to hit hole again. Again, it selects everything. I don't want that. I'm going to deselect these two. This one's now going to be a countersink. It's still a simple hole, meaning it's the size that you say it is. It's not threaded or clearance hole. It's a simple hole. It's a countersink this time. All right, so that's this shape. This shape you've probably encountered before if you ever put together any toys or anything. So let's go back and double check the stats. Countersink 0.75. The top of that seat is, the angle is 83 degrees and the width is 0.375. So let's just check our stats here. So the angle is a little bit different, right? This one's default is 82. 83 is what this is calling for. That's that. We'll do another hole. All right, hold down Shift, select this. And now this one is what's called a tapped hole or a threaded hole. Tapped is the language of the machinist, of the software here, the tapped hole. All right, so it's a simple hole, or sorry, it's not a simple hole, it's a tapped hole, and it has no seat. All right, then I have to select the size. Let's go double check that. I think it said a 1/4 inch, is it? Third hole, 1/4 inch, 1/4 by 20 UNC. So it's the tapped holes are very specific to the size and the profile of the threads, right? You can't just have any thread. If you go to Home Depot or anything and you buy screws, they have coarse, they have fine, then they have metrics, which run a little bit different. And this you know, 1/4 by 20. I don't remember if 20 is coarse or fine. Through all, termination, through all, hit OK. Now, the thing is with threading, tapping holes in Inventor, it doesn't actually thread it. It just makes it look like it's threaded. So when you make a mechanical drawing, you can tell. Because really, you wouldn't 3D print something threaded. You might just for fun, but really what you'd do is use a screw or something called a tap, and you cut that thread out of the plastic. You wouldn't print it that way. All right, so this one now is not a tap hole, it's a clearance hole, I believe. And what a clearance hole does is it opens up the hole to be a little bit wider so a screw can easily fit in there, or an axle or something can easily fit in there. It has a default extra cut clearance size, so you pick it based on the screw you're using. So it's a 1/2-inch hex head bolt. All right, so I got a clearance hole, size 1/2 inch, and it's a hex head bolt. So that makes it look nice. All right, 1/2-inch hex head bolt. Very cool. What happened here? Didn't go. Hole, 1/2-inch hex head bolt. There we go. All right, and that's it for the drilled holes ones. Any questions? Any questions in here? The drilled holes ones? Pretty self-explanatory. Let me just quick see why I'm shooting this video, if there's anything else interesting to show here. The loft is pretty straightforward, but that's one of my favorite things, actually, the loft. That actually is one of my favorite tools to use. All right, where is it? You can make really cool designs with the loft. So loft, you click the sketch, and if it's a simple geometry, it'll automatically select it. If there's only one closed surface in the sketch, when you select the sketch, it'll automatically find it. We'll talk more later on about what the rails mean. Basically, if you get to a project and you're going to try to use rails, I'll show you how to do it. And you hit OK. There's that loft, very cool. After that, circular pattern is just like regular circular pattern. Rectangular pattern is the same as doing sketches. The only thing is, when you do those, just you have to select this feature that you want to pattern, right? Rotational axis. You can select the axis or any of the cylindrical things you can select as well. Anything that's circular you can select and it'll go around it. And 10 times, okay. So change that to 10. Oops, 140, it's not going to like that. That's kind of cool though. Alright, yep. Rectangular pattern is pretty straightforward. This one's a little bit harder to select. So when you go to rectangular pattern this, you gotta make sure you get it. Oh, that's got it pretty easily. That's the thing you're patterning. Then you select the directions, right? Direction 1, direction 2, flop direction 2, so it's going right. Change the numbers. The one I do want to show you though is pattern along a path. Fusion 360 people, I already showed you how to do this. The mentor people though, I think some people in the class right now are on this one and maybe a little confused. Let me change my view here. View, visual style, shaded with edges, so you can see the edges. That makes things a little bit easier to see. All right, so it's a rectangular pattern, okay? And you select the features you want to pattern. Then we got to select the path, right? I think there's, what do we say, Ryan? 12 of them?
Yeah.
Okay, and spacing says it's 1. Now, that doesn't look like the, oh, they have 13 in here. Oh, that's right, we had that problem. You got to pay attention because look, direction 1 identical, direction 2 you select direction 1 as direction 2. That bends it around the line. Like this first one, let me do 13. I don't remember seeing that option when I was helping somebody in class here though. Bring this up here, orientation, direction 1, and then it bends it around the corner. Yeah, this one worked fine at 13, so I don't know what was going on there. So you got to select this option. You can see that in the window, but it's hard to see. So after you select the features, change your size, your shaping, then you got to bring up this extra menu option and click direction 1. All right, and hit OK. And then it looks more like the actual thing. Still not perfect though, you're right. That's pretty kind of ugly, but it's actually pretty ugly in here as well. Shell, I think this number's wrong. The 0.3125. The other ones are pretty. Coil, look carefully at the coil, right? But let me show shell here real quick. I only got a few more minutes here, so I'll end this up and I'll post it. So those of you that haven't been paying attention in class, maybe watch this on remote day. Then you can come in next time and really get going. Lunch tray, there it is. So when you hit shell, this is a nice tool. You got to select this face you want to remove. So remove that faces. I think it's 0.03125. I think that's what it's intended to be, not 0.3125. That makes it nice and thin, which is pretty cool. Pretty cool that it can do that. The more complicated this object, though, the less likely it is to be able to shell. If it's nice geometric shapes and simple fillets and chamfers, it'll be able to shell it, but complicated it's not. Paper clip, that's a sweep. Sweep, this is a nice tool. So you draw a continuous line in one plane, and then on a plane tangent to that line, you draw the shape you want to sweep. So the profile, it's already selected. There's only one closed profile to select. Then you select the path, and it follows that path. You can actually twist it. So if it wasn't a circle, it was like a square, you can actually twist it along the path, which is kind of cool. Hit OK, yes, there's that. The coil, most of them are pretty, where is it, coil? Spring. All right, so this one looks weird because you want to zoom out a bit so you can see the other line. Oh, it's not visible. All right, so when you hit coil, here's what you do. You hit coil, it automatically selects this profile. Now for the axis, you want to select the vertical axis, the y-axis. All right, so that's going to wrap this shape around that axis, and you can adjust the coil size and coil ends. So let's go and look at the coil size here. Height 6, revolution 5. Pitch, height, pitch, and height 6. I want revolution and height. Revolution and height 6 and 5. Revolution and height. Coil ends. Let's see. Anything there to tell us? Nothing about coil ends. Yeah, you can taper it if you want, but it doesn't really matter. You might fill it at the end, right? Round it off. So that's how you do the coil. You have to do it around the y-axis. Anything else there? Let's see. Threaded. That's basically the same as what you just did for the tapping. Filleting, chamfering, pretty straightforward. You change the distances and then click the edges and it'll cut them. Mirroring, you select this, you mirror it across its own plane. Emboss, select that. Maybe I'll make a video later on about that stuff. But I'm going to stop this for now. Hopefully that's enough to get everybody going. Oh, bell rang.